Hello and welcome to my channel, and as you all know, we are doing the problem session, and in this series we have already completed 9 problems based on various topics like resonating structures, stability of structures, aromaticity, carbocation, carbanion, steric inhibition of resonance. Now the problem number 10, we are going to start a new topic, acidity and basicity. So let us first see the problem and we'll see how the acidity in organic species is decided. Now, if you see the question, if you see the compound I have given, this particular compound on your screen has got 5 hydrogen which I have mentioned. 5 hydrogens are mentioned in this compound under name A, B, C, D and E. Okay, as you all can see on your screen. You have to see and analyze what is their acidity strength, and then you have to prioritize these hydrogen in decreasing order of their acidity. I have already told you, whenever you talk about acidity, what you have to do is to take out that hydrogen as H plus, and the minus charge will remain with the atom from which that hydrogen was earlier attached. Okay, so an anion will be left behind and H plus will go away. So you have to make all those anions one by plucking the hydrogen number A, B, C, D, E one at a time. So I'll be doing that, and I will start with the hydrogen number A first. Okay, so as you can see on your screen, I have taken away the hydrogen number A, and as I took away the hydrogen number A, this particular carbon from where it was attached will get a negative charge. You should understand, I have already spoken a lot about this. The creation of charge, okay, it has to be dealt very properly, because the creation of charge is something which makes the thing unstable. Okay, it is a burden, so you have to reduce the burden, and more you reduce the burden, higher will be the stability of that anion, and easily it will get formed. And once you say easily it gets formed, then that easily the proton is also going to go away from the compound and the acidity will be higher. Okay, so you have to check the stability of this anion, and as you see that this anion is in the neighborhood of the 2 pi system. As you can see, the 2 pi systems are in the neighborhood. You see there is a possibility of conjugation. How? Minus, single, double from left side, and from right side also you can see similar situation, minus, single, double. So after witnessing this, you are now assured that this negative charge is not localized, rather it will undergo delocalization, left also, right also, and there is a resonance stabilization, and it is good for the health of the anion, the carbanion in our present case. So as you try to make those resonating structures, you can do so. For an example, if you do it from the left side, minus, single, double, so you have to take these electrons like this, one position ahead, it will float, and simultaneously these pi electrons are going to sit on this particular carbon. So this particular carbon is going to get the 2 electrons as a lone pair, and a minus charge will come. Simultaneously from this carbon, as the electrons are going away, it will acquire a plus charge, and plus, earlier it had minus, plus minus will become 0, and these 2 electrons will make a pi bonding ahead. Okay, so you have seen the delocalization of negative charge from left hand side. Now the same thing, the similar thing you can do from the right side also. If you do it from right side, you understand, again you find minus, single, double, so you can float these electrons like this and put these 2 electrons on this particular carbon now. So this particular carbon is now going to get the 2 electrons and the minus formal charge, and these 2 electrons going to float to make a new pi bond. So what you have seen that after plucking the proton, after plucking the hydrogen from the site A, you have created an anion. The ease with which that proton is going to go away as H plus depends on the stability of the anion being created. And the stability of anion is judged by many factors like resonance, like inductive effect, out of which the resonance is a very important and prominent effect. Now as you try to see the possibility of resonance, you find that this negative charge is under cross conjugation situation. It is in conjugation left side also and right side also, and on that behalf you have created altogether 3 resonating structures. So there is a fair enough delocalization of negative charge which gives strength to the anion, okay, and hydrogen is fairly acidic. First of all, we are going to dissect each anion one by one, then we'll come to final conclusion afterwards. Now coming on to the hydrogen number B. Now hydrogen number B, as you all can remember, was the hydrogen which is, as you can see on your screen, the hydrogen number B is attached with the COOH group. Now as you are going to take that proton out, as you take that proton out, as you understand, the minus charge will come on this oxygen, and then after the anion is created, it's your responsibility to see whether the anion is stabilized or not. More it is stabilized, more will be the ease of hydrogen to go away as H plus, and higher will be the acidity. Now as you pondered over the structure, you found that there is a conjugation. How there is a conjugation? Let us try to see. You can simply see the minus charge, single bond, double bond, and this is a situation of resonance. After the situation is encountered, you do the resonance, this minus will go like this, and simultaneously the pi will shift on this oxygen. So from this oxygen the electrons are going away, so plus will come, plus earlier minus was there, plus minus becomes 0 formal charge, and as they float they make a new pi bond, and as you can see a new pi bond has been created, and simultaneously the pi electrons are shifting over this oxygen and they will be bringing a minus charge on that oxygen. So you can see you have created 2 resonating structures. Now at this point you have already seen that in A you can see there were 3 resonating structures, okay. What is the special, what is the which atom is bearing the negative charge in all the 3 structures? You should also give a good consideration. The carbon is bearing the negative charge in all of the 3 resonating structures, okay. Now 3 resonating structures, and the atom bearing the negative charge is carbon. Now coming on to the B anion, you find that there are just 2 number of resonating structures. On that ground it is having less quantity of resonating structure, but you should not forget that quality is a very important feature more than quantity. Although this structure, this carbene, this anion B had just 2 resonating structures in comparison to the earlier 3, but these 2 are much stabler than the 3 structure you drawn for the A anion. How? You understand, in both the structures, first of all, the oxygen is holding the minus charge. The oxygen is much ahead in its power to hold the minus charge because it is much more electronegative than carbon. The minus charge on the oxygen won't mind as it minds on being on carbon, okay. So the quality of the 2 resonating structure, which are equivalent also, as you can see, the minus charge is equivalent flowing on from one oxygen to another. So the structure, the anion B in that sense is a better option. Although less in the quantity, the quality is holding it at the top position amongst A and B. Amongst A and B. Now coming on to one second. Okay, charging was an issue. So now coming on to C. If you see the question in question, you can simply see that this is a carbon. This is a carbon at the apex, and it has 3 hydrogen, out of which 1 hydrogen we are talking about. So coming on to that, once you remove that hydrogen, once you have removed that hydrogen, student, the minus charge will come on this carbon, as you all can see. Okay, now you have to consider whether this anion is stable or not. After looking at this carbon, you immediately recognize that there is no possibility of conjugation. How you have decided that? Let us try to see it by singing the song of conjugation. Minus, single, single. From left also and from right also, minus, single, single. Now this is not a situation of conjugation. You should have minus, single, double. That is the situation of conjugation. But saying minus, single, single, that moment there is no conjugation. There is no scope of conjugation. So you have finally realized that this carbene ion is coming with a demerit. The minus charge is going to be localized on this carbon, and because of localization, because of the absence of delocalization, as we saw in the 2 cases earlier we have read, A and B, this is not as stable as we have found A and B. So C has got demerit, that there is no resonance stabilization. Now coming on to the hydrogen number D, and as you can see, the hydrogen number D was attached with this oxygen. So we are going to put this off from this position, and as you do that, the minus charge comes on this oxygen. Now again, oxygen is a good element to hold the minus charge, first of all, and second of all, you should understand the resonance possibility is also present. How? Let us try to see. Minus, single, double. So as you see this possibility, you do the resonance, and in that case you will float this charge like this, and simultaneously it will sit on this particular carbon. So this carbon is going to get a minus charge, and this minus charge floats, and there happens a pi bond now, and this pi bond is no more because the 2 electron will now sit on this carbon, bring a negative charge to that also. Now you have seen we have 2 resonating structures. Okay, in A you saw 3 resonating structures like this. In B you saw 2 resonating structures. In C no resonating structure. In D you again found 2 resonating structures. Although it has 2 resonating structures, student, but it has a good merit. What is the merit? One of the structure is having the oxygen element bearing the minus charge. In other case, in other resonating structure, it is the carbon. Now you understand. If you see the carbene ion A, if you see the carbene ion A, you see all the 3 resonating structures, the negative charge is borne by carbon, which is less electronegative, and on less electronegative element, negative charge does not suit much. Okay, if you see the B carbene ion, then you find that although 2 structures were there, in both the structure the very powerful oxygen was bearing the negative charge. So it's a sort of king type structure. Okay, now coming on to the D, although it has less number of resonating structures in comparison to A where you had 3, but quality wise, if you see the quality of the structure A where the oxygen is bearing the minus charge is making it better than the option A. Okay, because quality is winning over the quantity. Okay, now coming on to comparison of D with B, where you again got two resonating structures, but in both the structures, in the case of B, the minus charge was borne by oxygen in both the resonating structures. So there both the structures were equivalent, and in both the structure a very powerful oxygen was bearing the minus charge. But in the case of D, only one structure the powerful oxygen is bearing the negative charge. In the next structure you find there is a demerit, again the minus charge comes on a less electronegative carbon. On that basis you can see that D is lacking behind B. Okay, so we have till now done a comparison between A, B, C and D. Now coming on to E, as you can understand, in the case E, there is a localization. You can simply understand there is a localization of negative charge after you have removed the proton number E. The minus charge comes on the oxygen. But why I'm saying localization? Because there is no conjugation. You can see how minus single single. So there is no delocalization of the negative charge. However, the very powerful oxygen is bearing the negative charge. So quality wise it is again ahead of the carbene ion A. Why? Because in A, although you had three resonating structures, but in all the three resonating structures you had negative charge on carbon. Here, although you have one resonating structure, but that is a powerful structure. Why? Powerful in terms of what? In comparison to what? A, where you had that on the carbon. Here you are having it on the oxygen. So that is making a sense that the quality is winning over the quantity. Now coming on to a wide comparison. Now we are going to do a good comparison between all A, B, C, D and E. Coming on to the comparison, if we start writing some points over the hydrogens which we have already discussed, you understand in the case of A the resonance was there. Okay, in the case of B still resonance was there, but it is a power, it had two powerful resonating structures because the minus charge was borne by the two oxygen atoms. In the C, resonance was absent. In the D, again resonance was there, and this resonance was, as you had seen, is powerful than A, because here the minus charge will come on oxygen, but in the A, nowhere you saw the minus charge coming on the oxygen. And in the case of E, you saw, although only one structure was possible because the conjugation was not there, but still the minus charge remains on powerful element O, more electronegative element O. So in the nutshell, I would like to conclude that once you have decided that the minus charge is on more powerful element, more electronegative element, put those front runner. So if I try to put the front runners, so front runners are the B, the D and E. Why these are front runners? Because in all these cases you had at least one of the resonating structure where minus charge was on oxygen. So quality wise these are leading, and after that comes the A and C, because in A and C both the cases you saw the minus charges remaining on the carbon, although A had delocalization still on the carbon, but C lacked that also. So now if you see B, D and E, they are having at least one resonating structure where the minus charge is on O. You should not count how many more structures you can get where powerful element O is bearing the minus charge, and simply one option comes in your mind, that is the B, where both the structures had minus charge on oxygen. So B is the clear cut winner. Okay, then after B you realize that amongst D and E, in the case of D and E, in both cases the minus charge was on oxygen, but the D had a positive feature. It had a merit over E, that there was a delocalization, there was a resonance, but in the case of E, the resonance was not present. So on that ground, you can say that after B will come D, then will come E. Okay, and amongst A and C, I have already talked about that. In A you had 3 resonating structures, but in C there were no resonating structures of that, and only one resonating structure, only one structure was there, because in E the minus charge, in C the minus charge is not getting delocalized. So on that ground, you can, after E, put the A, and finally comes the C. So this is the final answer of the ease with which the proton, the hydrogens are going to get released as proton, as H plus, and therefore the acidity order. So I have tried all to dissect each of the comparison to its fundamental level, to its basic level. I hope you must have understood the basic details, and like these we will continue looking at the different varieties of problems on different topics. Till then, take a good care of yourself. Thank you very much.